Welcome to another physics class. Today, as I promised, when we concluded our last lesson, that we are going to look at calculations on work done. So today, let me remind you what we have done so far in our last lesson. 1. We said work done in horizontal plane is equal to WD, which is equal to force multiplied by displacement. That is work done in an horizontal plane. 2. Work done against gravity. That is, WD is equal to mgh, mass of the object, acceleration due to gravity, and the height attained by the body. Then number 3, we talk about work done in an inclined plane. Inclined plane as WD is equal to F cos theta D, where F is the force applied, theta is the angle of inclination, and D is the distance of displacement. At the same time, number 4, see under inclined plane. Let's call this one 3A, then 3B. Under inclined plane, we talk about force parallel to the plane. Force parallel to the plane, which we said F is equal to W sine theta. That is force parallel to the plane, either to pull or to pull down the object. So we came across all this formula in our last lesson. So today, our calculation will be on how to apply all this formula to solve problem. Let's take this one as example 1. But mind you, as I said, if you are just joining us on this platform, please don't forget to like, share, and subscribe so that when I upload a new video like this, you'll be able to get the notification in time. And for you to understand this topic better, please try as much as possible to watch our last video on work. Let's take this one as example 1. An object is dragged horizontally across a surface by a force of 100 Newton through a distance of 8 meters. Calculate the work done by the force. Solution to this one. The parameter given, force is given. F is equal to 100 Newton. Distance is given. D is given as 8 meters. Now the question now has to calculate the work done, WD, question mark. So from this one, work done now, without wasting time, will be equal to force multiplied by distance. And the force given is 100 Newton, then multiplied by 8. So the work done by the force now will now give us 800 joule. That is the simplest example that we can have under this calculation. Let's take this one as example 2. A lift carries 12 peoples of average mass of 7.80 kg through a height of 45 meters. Calculate the work done by the lift engine. G is equal to 10 meters per second squared. Now to solve this one now, let's list out the parameter given in the question. Mass of these 12 people, the average mass is given. So that will be M is equal to 7.80 kg. Height to which the leaf then h is equal to 45 meter. And acceleration due to gravity, g is given 10 meter per second square. Now to calculate the work done. So work done, this work done is against gravity will be equal to mgh. Then this one will now give us 7.8 multiplied by 10 multiplied by 45. So this one will be equal to 780 multiplied by 45. The work done by the lift engine will now be equal to 35,100 joule. That's the solution to the question number 2. Let's take this one as example 3. A body of mass 50 kg runs up a set of 6 steps, of which the height of each step is 0.5 meter. Calculate the work done by the body. G is equal to 10 meter per second square. The first thing, we now say that this one also is work done against gravity. So, and you know the formula of work done against gravity, work done is equal to mgh. Now from the question, mass is given. M is equal to 50 kilogram. G is 10 meter per second square. And h, according to the question, 6 steps, each of 0.5 meter. So that will be 6 multiplied by 0.5. Then this one will now give us 3 meter. That's the total height of the 6 step. So from there now we can now say work done again by the body will equal to 50 multiplied by 10 multiplied by 3. So this one will now give us 500 multiplied by 3. And this one will now give us 1,500 joule. So the work done by the body will be equal to 1,500 joule. Let's take this one as example 4. A boy pulls a box along a horizontal ground with a force of 300 Newton inclined at angle of 60 degrees to the horizontal. Calculate the A, vertical component of the box, B, horizontal component of the box. Now, C, work done by the boy if the box is pushed through a distance of 5 meters. Now, solution to this one. Now, from this one, force is given. F is equal to 300 Newton. The distance pushed D is equal to 5 meters. But according to the question, let's say this is the box and the force applied by the boy is 300 Newton. The angle made with horizontal is 60 degrees and he pushed the box through a distance of 5 meters. Let's say this is the diagram and this is 300 force. Now, the first question says we should calculate the vertical component of the force. Vertical component, when you draw it like this is vertical. Call it Fy. The force is on this direction. Now, if we want to calculate the vertical component, we make use of this side and the angle. So mind you, this is the direction of the force. Now, to calculate this one, and that one will now give us, this is opposite over hypotenuse. That will be sine 60 degrees is equal to Fy over F. Therefore, for the Fy will be equal to F sine 60 degrees. That is for vertical component. of the bus. Now our f is 300. So Fy now will be equal to 300 sine 60. And sine 60 is 0.866. That will be 300 multiplied by 0.866. Therefore, our Fy, which is vertical component, will be equal to, the answer is 259.8 Newton. That is for the vertical component. The next question is for horizontal component. When it is horizontal, you consider this line as Fx and the force given, then the angle. So therefore, this one will now give us, for horizontal component, which is big question now, it will now give us, that's adjacent and hypotenuse. That's cos 60. That's cos 60 degree is equal to Fs over F. So our Fs now will be equal to F cos 60 degree. So this one is for horizontal component of the bus. Horizontal component of the bus. So our Fs now will be equal to, our F is 300, then cos 60 degree. Cos 60 degree will give us 0.5. That's 300 multiplied by 0.5. So this one will now give us 150 Newton. That is for horizontal component of the bus. The next question says we should calculate the work done by the bus if it is being pushed by through 5 meters. And don't forget, in our last lesson, I explained that when you have a question like this, we will resolve it to horizontal and vertical component. The work done by the boy, this is the direction of the force. For the vertical, the direction of this vertical component will be perpendicular to the direction of the force. Since the direction of the force for this Fy is perpendicular to this one, so the work done along this Fy will be equal to 0. But it is only on the horizontal distance now, in which the direction is in the same direction of the force, so that the work will be done. So work done now. Number C question. Work done now. Work done, which is equal to F multiplied by D. And we say it will be Fs. So that one will be Fs now. Why is it Fs? Because Fs, the force Fs, is in the same direction of the force applied by the boy. So we are going to have multiplied by the distance. So this one will now give us, the distance given is 5 meters, and this one will be 150 multiplied by 5. So the answer for work done will be equal to, will be 750 joule on the horizontal ground. Let's take this one as example 5. An object of mass 50 kg is placed in an inclined plane or at 30 degrees to the horizontal. The height of the inclined plane is 250 centimeters. Calculate the work done in moving the object down the plane. G is equal to 10 meters per second squared. So to solve this one, solution, let's first write out the parameter. Mass is given, F at 50 kg. Angle theta is given, 30 degrees. Then height of the inclined plane, height, h, is equal to 250 centimeter. Then G is given, G 10 meter per second square. So we now have to calculate the work done in moving down the plane. Now, let's draw the diagram to see how the solution will look like. Let's say this is that object that will be moving down the plane. Don't forget that this question now, I joined the work done to the coefficients of friction that we've done. This place is 30 degrees. And to move this object, as I said, the parallel force that we had on the plane will be equal to W sine theta. Don't forget that. So since the force that we require for this one is equal to W sine theta, because it will move down the plane. Now, then the distance from here to here, that's the distance. Now, we don't need the vertical distance. That is, the height of the inclined plane is given 250 centimeter. And you know that the work done is equal to force multiplied by distance. And mind you, this is the vertical distance. We want to calculate what and get this one to be equal to 0 as we explained in the other example. So the first thing we need to look for is the distance, the horizontal distance. So if you look at it now, to calculate D now, to calculate D, if you consider this one and this distance and this angle, that will be opposite over hypotenuse. So that will be sine 30 degrees is equal to 25 over D. So cross multiply will give us D sine 30 degrees, 250 equal to 250. So from there now you can now have D now will be equal to 250 over sine 30. And don't forget sine 30 is 0.5. So D now will be equal to 250 divided by 0.5. Now D, as I said, will equal to 500 centimeter. But mark you, the acceleration due to gravity is given in meter per second. So we need to convert this one to meter. So to convert it to meter, we now say D now is equal to 500 over 100. So D now will be equal to 5 meter. So since we got our D as 5 meter and our F, according to what I've written on the board, is W sine theta, we can now say work done now will be equal to W sine theta multiplied by D. Don't forget this one is different from ordinary horizontal plane, in which we say the work done will equal to F cos theta D. But this one is sliding down. We will need to consider the parallel horizontal force as we have done under coefficients of friction. Don't forget, if you have not worked that one, please, you can go back and watch our video on coefficients of friction, which we say we made as A and B, so that you can understand how we got our this horizontal constant force. So from there now, the mass is given. Don't forget, W is equal to mg. That will be mg sine theta d. So that, and the mass of this is 50. So that will be 50 multiplied by 10 multiplied by sine 30 multiplied by 5. So this one will now give us 500 multiplied by sine 30 is 0.5 multiplied by 5. So the work done now will be equal to, the answer, as I said, will be equal to 1,250 joule. That is the work done. Let's take this one as example 6. And the question reads thus: a crate of mass 50 kg pulls up a rough inclined plane at an angle of 60 degrees to the horizontal. Calculate the total work done in moving the crate to the top of the inclined plane 20 meter high. G is equal to 10 meter per second squared. Now, solution to this one. Let's first write out the parameter. Mass is given M as 50 kg. The angle to the horizontal is 60 degrees. Then what else is given? G, the height of the inclined plane, H, is equal to 20 meter. Then G, acceleration due to gravity, 10 meter per second squared. To understand this one better, please, as I said the other time, this one I've joined coefficients of friction with work done. Now, for you to understand this one better, please try as much as possible to watch our lesson on coefficients of friction in an horizontal plane and in an inclined plane. So the angle of inclination here now is 60 degrees according to the question. Now, this crate, let's say this is the crate, and the crate need to be pulled up. Let's call the force that we pull it up as P. Definitely, as we learn under coefficients of friction, then there will be parallel horizontal force, which is F, which is W sine theta. And since this one is pulling up, then the frictional force, Fr, also we have in the same direction of the parallel force. So from this one, mind you, the question said the height of the plane is 20 meter. So from this one now, the length of this inclined plane will be from here then to here. That's distance, because we need distance, because our work done will be equal to force multiplied by distance. Then we still need to find the total force. So let's first calculate D now. So using the diagram on the board, D, to calculate D, this is opposite, this is hypotenuse. So D now be equal to sine 60 degrees is equal to 20 over D. So we are going to have D sine 60 degrees is equal to 20. So our D now is equal to 20 over sine 60 degrees. Then sine 60 is equal to 0.866. Then 20 divided by 0.866 will give us 23.095. Approximately, our D now is equal to 23.1 meter. That is the distance from the bottom of the plane, inclined plane, to the top. Now, as I said, this question has combined coefficients of friction together with work done. Now to calculate the total force now. This P, our P will be equal to F, that is the parallel cos horizontal force, plus Fr. So P will now represent our total force now. If P is our total force now, and we have already know the value of D, then this one will now give us W sine theta plus coefficient of friction is not given. And frictional force is not given. And don't forget, from what I've done under coefficients of friction, we say FR is equal to mu R. Now, don't forget, let's first find mu, and mu will be equal to tan theta. Don't forget, we done all this one under coefficients of friction. So as I said, if you want to understand this question better, please try as much as possible to watch our video on coefficients of friction in an inclined plane. So our theta is 60. So this one will be equal to tan 60 now. And tan 60 will give us 1.732. Mind you, coefficients of friction is a dimensionless quantity. It has no unit. So also, R is normal reaction force. Normal reaction force. And don't forget, in our last lesson, under that coefficients of friction in an inclined plane, we say R will be equal to W cos theta. How we arrive at all this one, we explain in detail under coefficients of friction. So this one will now give us 50 multiplied by 10 multiplied by cos 60. Mind you, cos 60 is 0.5. So we are going to have 500 multiplied by 0.5. So this one, without wasting time, will give us 250 Newton. Having known the value of coefficients of friction, mu, and the normal reaction, R. So the coefficients of friction, F, and the frictional force, F, will be equal to mu R. That is the value 1.732 multiplied by 250. The frictional force now will now give us 433 Newton. Don't forget, we said total force will give us F plus FR. We've known the value of FR as 433 Newton. Then let's find F out. P is equal to F plus FR. And this one will give us, we can now say, but F is equal to W sine theta. So that one will now give us mg sine theta. That's 50 multiplied by 10 multiplied by sine 60. So this one will now give us 500 multiplied by 0.866. Our total force will now give us, our F will now give us 433 Newton. Therefore, our total force will now give us 433 plus the 433 that we arrive at here. That will be 433. Sum together will now give us 866 Newton. So if our total force now is 866 Newton, and here now we said our total force, let's say this one also to Ft, and say this one to Ft to make it tally. So since our work done is equal to total force multiplied by the distance, and the distance we calculated is 23.1 meters. So we can now say work done, the total work done, and according to the question, total work done, WD, will be equal to 866 multiplied by 23.1. Total work done, as I said, we equal to 20004.6. That is from this formula. We say that work done is equal to total force multiplied by the distance moved. So, according to the question, now we've answered the question that we say we should calculate the total force, which is equal to 2004.6 joule. joule. Total work done will be equal to 20004.6 joule. Now let's take this one as example 7. Two forces of 4 Newton and 6 Newton act on an object at an angle of 60 degrees to each other if the object is moved through a distance of 5 meters in the direction of the resultant force F. Calculate the work done on the object. Calculate the work done on the object. Solution. Now we are going to two forces act at an angle 60 degrees to each other. Let's draw it and see how it will look like. Let's say this is the first force, 4 Newton, and the second force, 6 Newton, act at an angle 60 degrees to each other. Now, their resultant force will now be drawing, making use of parallelogram law of vectors or forces. So, I now draw it like this. This is the resultant force, F. Again, that's clear. So, if you now extrapolate this line, this angle will be equivalent to this angle, 60 degrees. And without wasting our time, this angle, you call it angle alpha, then angle alpha will be equal to 180 minus 60, which is equal to 120 degrees. Now, to calculate the resultant force now, then, according to the parallelogram law of vector, this side is 4 Newton, this side also, for a parallelogram, opposite sides are equal. 4 Newton, 4 Newton, 6 Newton, 6 Newton. So this place also will be 4 Newton. So if that is the case now, for this one now we are going to apply the cosine rule. Apply cosine rule. That one is from mathematics. Now, as I said, to apply cosine rule for this one, it will give us F square will be equal to 6 square plus 4 square minus 2 multiplied by 6 multiplied by 4 cos 120 degrees. That's the cosine rule from the mathematics. That is, we want to calculate this line F as our resultant force. The opposite angle, as we have calculated it, 120 degrees. The side adjacent to the angle. So that's the cosine rule. From there now we can now see F square will be equal to 36 plus 16 minus 6 multiplied by 4 will be 24. 24 multiplied by 2 will be 48. 48, then cos 120 will give us negative value. That will be minus 0.5. Don't forget the trig ratio in mathematics. When you draw it like this, for quadrant, both sine, cosine and tangent will be positive. And for quadrant rate from 0 to 90. Now from 90 to 120, 180 now, then only sine is positive. Cos and tan are negative. So sine 120 will fall like this. Cos 120 will fall like this second quadrant. So that is why we got the minus the 0.5 from the source. So from this now, 36 plus 16 now square will be equal to 52. The negatives na negative we give for positive 48 multiplied by 0.5 we give for 24. So from there, our f square now will now give us 76. 76. So f now will equal to square root of 76. Then f will finally give us 8.718. That is Newton. Now, since we got the resultant force now, and don't forget, the question says the object is moved 5 distance by through the distance of 5 meters. So we can now say our work done in moving the object will equal to F multiplied by D. That's 8.718 multiplied by 5. So work done in moving the object through a distance of 5 meters will be 43.59 joule. That's the final answer. What we have done today under this lesson, that is under the calculation of work done, we done enough justice on the subtopic, but if you still have any question based on this topic or on another topic in physics, you are free to ask your question under the link on the channel. As I said earlier, please, if you are not with us before, please try to like, share, and subscribe so that when I upload a new video like this, you're able to get the notification. Thank you.